Welcome back to Math 171 Pre-Calculus Algebra. In this video, we're going to talk about finding the zeros of polynomials or solving a polynomial equation. It's really very similar concepts because finding zero is just solving the polynomial equal to zero. So I'm going to deliberately start with something that is not equal to zero. So x to the fourth minus 6x squared minus 8x equals negative 24. The reason I deliberately started with something that doesn't equal zero is that anything we're going to do as far as solving a polynomial, we need this to equal zero. So we can do that by adding 24 to both sides of this equation. So we end up getting x to the fourth minus 6x squared minus 8x minus 24 equals 0. Well, now we can start listing our possible zeros here, which would be 1, negative 1, 2, negative 2, 3, negative 3, 4, negative 4, 6, negative 6, 12, negative 12, 24, and negative 24. So really at this point it's just going to be to guess and then check based on these numbers. Now I would not recommend starting with numbers like 24. Instead I'd recommend starting with the small ones, although when I have stuff where the leading coefficient isn't 1, I do like to start with integers. So I'll just start by testing to see if 1 is 0 this polynomial. So remember, I need to put the 0 in there for the x cubed term. So I put those numbers in, and now I test. So 1, bring down the 1, multiply by the 1, and add. 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 I get 11, that's not 0, so I can completely eliminate 1. So, let's try something else. We'll go ahead and try negative 1. Oops. So I bring down the 1, multiply by negative 1, and add. Multiply by negative 1, and add. Multiply by negative 1, and add. And multiply by negative 1 and add, I get 27. 27 is not 0, so I can eliminate negative 1. And now we'll try something different. So let's try 2. So I bring down the 1, multiply by 2, and add. Multiply by 2, and add. Multiply by 2, and add. And multiply by 2, and add. I get 0. So I now know, based on the factor theorem, that x minus 2 times x cubed plus 2x squared minus 2x minus 12 is a factorization of that polynomial we had to start with. Well, now to look to factor this further, I'm going to go ahead and just check for factors of this. I'm still going to look at the same list I have now, except I can now also eliminate 24 and negative 24 because those are not factors of 12. So I'm now just testing on the smaller polynomial that I got, x cubed plus 2x squared minus 2x minus 12. And there is nothing that says 2 cannot be a 0 again. So I'm going to go ahead and start by testing if 2 is a 0 of this polynomial. So 1, 2, negative 2, negative 12. Bring down the 1, multiply by 2, and add. Multiply by 2, and add. And then multiply by 2, and add. So I get 0 again. So I now have the x minus 2 that I had before. Now I have another x minus 2. And then for the remainder, remaining portion, I have x squared plus 4x plus 6. So now I could continue testing like this with the x squared plus 4x plus 6, but it's really unnecessary. So I know that equals 0, which tells me x minus 2 equals 0, or x minus 2 equals 0, or x squared plus 4x plus 6 equals 0. Well, here I get x equals 2. Here I get x equals 2. And then here I plug it into the formula. X equals negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 6 over 2 times 1. That's going to give me negative 4 plus or minus the square root. Simplifying that whole thing gives me negative 12 over 2. And then further simplification that I'm going to have to, I guess I do have more room over here. So negative 4 plus or minus 2i root 3 over 2, and then factoring out the 2 and dividing, I get negative 2 plus or minus I root 3. So we now need to write our zeros of this polynomial so we end up getting that they are the set 2, 2, that was negative 2 plus I root 3 and negative 2 minus I root 3. I am totally fine with you putting negative 2 plus or minus I root 3 there. And my math lab may insist on you not putting the 2 twice. The reason I put it twice, I'm going to talk about in the next video. The fundamental theorem of algebra tells us that because this polynomial was of degree 4, the highest exponent was 4, that it has to have 4 roots. So that will be in the next video.